to find the decimal expansion of fractional numbers. Okay. So before that, we know there are three types of decimal expansions, like terminating. Terminating means it will end, right? Terminating means it will have a end. Then non-terminating. Non-terminating, it can be of two types, repeating and non-repeating. Okay, all of you know this, like. Anyways, by seeing the fractional number itself, we can understand whether it is a terminating decimal or a non-terminating decimal. Okay, what we have to do is we have to check the denominator part of the given number. Okay, if the denominator is having only 2 and 5 as factors, then it will terminate. Okay, if the denominator of the given fraction number, if it is having only 2 or 5 as factors, then that fractional number, the corresponding decimal number will terminate. Okay, hope all of you understood. See, the theory is written over here. A number in PYQ form will have a terminating decimal expansion if and only if Q means the denominator part, has only 2 and 5 as factors, other than 1 and that number itself. Okay, we all know that a number will have a factor 1 and that number itself. Other than that, if 2 and 5 only comes as the factor, then it will terminate. See here as an example, 3 by 7 is given. Will it terminate or not? See, 7 factors. The 2 and 5 are not factors of 7. So we can say this will not terminate. So it is non-terminating. Okay, non-terminating. Then we have to think whether it will repeat or not. Okay, whether it will repeat or not. See, 3 by 7 means it is in P by Q form, right? P by Q form means it is rational. It is a rational number. Rational number means if it is non-terminating, then it should repeat. So non-terminating, repeating decimal it will have. If it is non-terminating and non-repeating means what? It is irrational. So it cannot be represented P by Q form. In our questions, all the numbers given, see, P by Q form will be there. That means it is rational. Rational means if it is non-terminating decimal, then it should repeat. Okay, see here, the denominator is 5. So we can say 2 and 5. 2 or 5 comes as the factor. Okay, here 5 is the factor, no other factors for this number. So we can say it will have a terminating decimal expansion. Now 5 by 4, here the denominator 4. The factors we know 2. 2 is a factor of 4. Okay, no other factors other than 1 and 4. 2 is a factor, 4 is a factor, and 1 is also a factor for the number 4. So see, the denominator other than 1 and that number itself, only 2 is there as a factor. That means it is also a terminating decimal. Okay, when we find out the decimal expressions, no, we will find that it is terminating. So first we have to check whether it is terminating or non-terminating. This is our first question. Find the decimal expansion of 3 by 40. Okay, 3 by 40. Here 40 comes as the denominator. When we factorize 40, see 2 times 20, again 2 times 10, then 2 times 5. See, only 2's and 5's are there as the factor of 40. That means we can understand that it will terminate. Okay, first we have to determine whether it is terminating or not. Then we have to divide 3 divided by 40. We know 3 is not divisible by 40, right? This way, or we can do another way. See, here we have 1 0, right? We can split it as 3 by 4 into 10. I think it will be more easier. Okay, this way we can do division, or this way I will explain. See, 3 by 10, right? 3 by 10 is 0.3, right? 3 by 10. See, 0 means here the actually 3 means the decimal is on right. It will move towards left because it is divided by a number having 0. So the decimal will move towards left one place. So it will come here. So it is actually 0.3, right? 0.3 divided by 4. Like that also we can do. I think this will be easier than this because division by 40 may be confusing or may be difficult, but division by 4 will be easy. So we can change it as 0.3 divided by 4. Okay, divided by 4. Now, here the first digit itself is 0, so we can put a 0 over here. Then a point comes here, so we'll put a point over here. Then 3. 3 is not divisible by 4, right? 3 is not divisible by 4. So what we have to do? It is not divisible. In maths, we have to put a 0 to notate that it is not divisible by 4. Next, after putting a 0 over here and already a decimal place is all there in the quotient, so we can add 0 here, right? Then 30. How many 4s are there in 30? You know, it is 7. 7 4s, 28. Then subtract, we'll get 2. Then already decimal is there. No, we can put one more 0, 20. 20 divided by 4, it is 5. So the answer is 0.075. Okay, if some kids have some confusion by division like this, no, 0.3 divided by 4, then we can directly divide 3 divided by 40. You'll get the same answer. See, 3 is not divisible by 40, so we have to add a 0 here, then a decimal point there, and then give 0. 30 is still smaller than 40. That means 30 cannot be divided by 40. We have to add one more 0 here to indicate that this number is not divisible by this divider. So after giving a 0 in this quotient part, we can give one more 0 here, dividend part. Okay. Now it became what, 300. So 300 divided by 40, we know it is 7 times. 7 times 40 is 280. So subtraction, so 20 is here. Then we, after giving the decimal, no, we can give one more 0, 200, so 5 times. So see, we are getting the same answer. In both these ways, we can do. This is our next question. Find the decimal expansion of 10 by 3. See, here the given number is 10 divided by 3. See, we know the factors. Factors of 3 will not have any 2 or 5, right? So it will not terminate. So the answer will be non-terminating. Then what? If it is non-terminating, and since this is in P by Q form, it is rational. So non-terminating as well as repeating. Okay. So we are expecting such a decimal expansion. Now let us divide 10 divided by 3. 3 times 3, 9. 1 comes as the remainder. Then we are not supposed to stop by this. We have to add one decimal point in the quotient. And after that, we can give 0 to this part, the remainder. Then again, we got a 10. Again, 3 times 3, 9. See, 1 comes here, 10, it goes on. So actually, the answer will be 3.333 like that, which can also be represented as 3.3 bar. See, 3 is getting on repeated, means we can give a bar over 3. Next is find the decimal expansion of 7 by 8. See, the denominator is 8. When we factorize 8, we know it is 2 cubed, right? See, 2 times, here 4, then 2, 2. See, only 2 is there after factor of 8. Enough. 2 or 5, only 2 or 5. See, as the factor means it will terminate. So we are expecting a terminating decimal. Okay, next we will divide 7 by 8. 7 is less than 8, so we have to put a 0 over here because less means we cannot divide directly. Then we have to provide 1 0 here. 70. 8 times 64. Then subtract 6. Again, see here we have already given one decimal, right? We can give 1 0 here. 7 times 56. Then 4 comes as the remainder. Then again we have to give 1 0. So 5 times 40. Like that it goes. So this is 0.875. This terminate.